Hello, everyone, and welcome to the Build Better Homes podcast. I'm your host, Royal Mortier with PLIRIS. And with me today, I have my always trusted co-host, John O'Shea. We have a special guest with us today, and that is Nate McIntyre with a company called CSF. Just a little background, Nate and I have worked together for about a decade on mainly construction forensics and building envelope projects. I thought he would be a great guest on this show because his background is very different from mine and John's. He brings a different skill set to the table that's very beneficial to builders and can really shed a light on a lot of things that are occurring present day with construction, energy code, water tightness, facade and materials. And so I thought this would be a great person to have on the show. So Nate, welcome.
Thank you. Thanks for having me, guys. I'm glad to be here.
Yeah, glad to have you. John, how are you doing today?
I'm doing good. It's another rainy day here in Oregon, but a great day for a podcast and a good day to talk about things, how we can find and fix and prevent air and water intrusion and hidden construction defects. So I'm excited to talk to Nate.
You're in Oregon, I'm in Florida. Nate, you're in Oregon, you're in the Portland area as well, right?
I am. I work all over the country, so I'll be in New Orleans next week, and I was in Florida a couple weeks ago. Got some stuff in Hawaii, so I get the joy of solving building problems all over the U.S. I love it.
Yeah, it's raining just water where you're at, John, and apparently next week we're going to have the risk of raining iguanas in Florida as our temps drop below 45. So look out for not exactly raining cats and dogs, but iguanas are definitely something to keep an eye out for. So.
Yeah, everyone wears hard hats around town, or?
It's all more in the southern Florida. I'm up in the Panhandle. That's apparently a risk you run walking under trees in Florida when it's cold. And then, something we'll discuss today is obviously the variables in temperature we experience and how those affect building materials, especially your building envelope materials. So, areas that are commonly well above 100 degrees, regular sun, stuff like that, are now going to have a very short-term event of being in the 20s and 30 degree temps, which can cause its own issues with building envelopes. So anyways, Nate, welcome to the show. Let's just go ahead and start at the beginning. How'd you get into this? Where'd you come from? How'd you get into the industry and go from there?
Yeah, I've had a really diverse background. I've been very fortunate to have worked in all sorts of different aspects of construction and design. And say I started my building science career working for an engineering firm for about 7 years. I got to work at a lot of high-tech facilities and hospitals and commercial buildings and just understand how the mechanical systems work and the physics of buildings and doing commissioning and test and balance and all that fun business. And then I got into about 2003, got my contractor's license and got into construction management and waterproofing and overseeing and doing some design on building envelope and just been doing it ever since. I would say around 2005, I started working heavily with attorneys and insurance carriers for builders that get sued or building owners that want to sue somebody for building failures. And I've been doing that for a little over 2 decades. So I'm the guy that they call when there's a problem. I help them figure it out and how to fix it. And I love it. So I have lots of anecdotal stories and fun war stories to share with everybody.
Very cool.
I have a question for you, Nate. How has technology kind of changed the game over the years? Has it helped you in your investigations and in things that you're doing and shaped how you go about those things?
Absolutely. When I started consulting, there was guys still in the industry. They would take 35 millimeter photos, get them printed, and they would tape them to sheets of paper and put them in a 3-ring binder. And they'd have typed notes or handwritten notes, and that was how people reported construction defects or did inspections. To now, what I use for every inspection, I use 3D modeling and 3D cameras and drones, and so I can go through and walk people through an entire building and it's not just a point and shoot. So it's come really, really far since, from when I started.
Gotcha.
I would say with technology, one of the things that I try to keep a beat on is the 3D technology and construction management and what people are using AI for and predictive computing, so those sorts of things. And that'd be fun to talk about today.
What is 3D modeling?
So there's different kinds of 3D modeling. So there's BIM, which is building information modeling. That's typically digital 3D. Somebody build a model of a design. So if Royal was to design a structure, then they would, somebody that was good at BIM would say, here's what it looks like. We've modeled it. This is what the building's going to look like when we put all the components in it. What I use is actually just a reality capture. So I call it 3D modeling, but it's essentially 360 photos that are all stitched together, and they create kind of a digital twin, if you will, of an environment. So we can all walk through it, and it gives you takeoffs, and you can take measurements of rooms and buildings, and it's really handy stuff.
Do you use infrared at all?
I do, yeah. So I just got asked that by an architect yesterday. They're concerned that their design's going to leak, and so what I told them was, well, you can install moisture sensors in a wall that will give you an alarm if it leaks, or we can do kind of ongoing surveys. We can do a benchmark infrared survey of the exterior and interior of the wall. And they come out every 6 months or whatever interval they want, and we can redo the scan, and you can see if there's any thermal anomalies or any changes or things that would be indicative of water loss.
And you kind of map those out in a mapping type of thing across an entire building or something, or for the layman on how that works. So there's actual sensors that go inside the wall.
Yeah, there was a company a long time ago, probably about 15 years ago, they came out with a system that was adopted from clean rooms. So clean rooms have these moisture, so they're kind of like ropes, and they put sensors underneath elevated floors. So if there's any leaks in acid baths or deionized water, these things will send an alarm off and say, hey, something's leaking, and it'll kind of give you a proximity of where it is. And so there was a company that did that for walls, and now there's another company that has come out and said, hey, you can put these flood sensors in your walls, and it'll give you an alarm if something leaks.
Is that
So
testing assemblies, like for different wall assemblies and different things like that? Because the normal person isn't going to have moisture sensor in their walls, right? They're going to call somebody, they're going to put that in, and they're going to test the assembly or the whatever they're trying to test, right? So it's mostly just like testing tools that those are in. Clean rooms are in there permanently, right?
Yeah. They put them in clean rooms. They, when they install them, they put them there, which is good because you have really sensitive equipment and some nasty acids and chemicals you don't want to come in contact with. But to your question, absolutely. I mean, we typically don't find that in homes. You don't find it in commercial buildings, or most buildings for that matter. This was just something that the architect called and said, hey, we're concerned about the design. Can we do something like this? And yeah, you certainly can. Usually my response is, well, just design it better and quit value engineering smart things out of your building so you don't have to do that.
Yeah.
But here we are. Most of what I do on the forensic side of things, when people call me, it's already a problem typically. I mean, when they get to me, it's like, well, the building's leaking, stuff's cracking, it's failing. Just like when they call Royal, they go, well, hey, we got these, the building's settling and it's cracked, and come look at the structure and tell us what's wrong and how to fix it.
I know I've seen like at Home Depot and Lowe's and all that, I've seen like sensors you can put maybe in the pan of your HVAC unit, or you're like, I know this is slightly different than what you're talking about, but there's moisture meters that you can buy just to test like the surface moisture on, let's say, a stud or something like that, or like an alarm you can put on your pan in your HVAC unit in case the condensation becomes too great or is overflowing. And I know that those exist for people who just want to be able to control or get a notification on an app or something if there's something going wrong at their house, so a little bit different, but I've seen those before as far as sensors go.
Yeah, and I do think, the future of a lot of this kind of stuff, we're kind of heading there. It was interesting to me that, it was a great idea, but it was so expensive, 15 years ago. And it came out of somebody just said, oh, well, let's take this clean room technology and we'll put it in walls. And I thought, well, that's a great idea, but it was really cost prohibitive to install and monitor and maintain it. So I do think in the future, though, people are going to lean towards that sort of stuff. So the manufacturers that are getting into this stuff and coming out with it, I could definitely see people saying, hey, let's just put these in the hot spots in buildings.
And smart homes and connected to their smart home or
Yeah.
something like that.
One thing that you and I have worked on it, and it's something that I've seen you do, is with your 3D modeling is coming in at different steps of construction and doing Matterport modeling of the home at different steps. Yes, you've got the sensors that we can install in there, but the other part is when you're doing your 3D modeling at those different phases, it makes it very easy to identify where elements actually are, right? So we do have a high moisture content in a wall. Well, maybe that's from a leaky pipe. Well, we know that pipe is actually coming in right between these two stud bays because according to the model, it's right here, right? And
Yeah.
so it makes it very easy to access those things.
I always tell people it's kind of like a digital time machine. If you do this thing properly, and to Royal's point, what I like to do is say you should scan from dirt all the way through to the completion of the project. And then you have time-stamped model that we can go back through time and say, where was it at this stage? What components were put in? And it also allows people, the engineers and the designers, to look at it from remotely. So Royal's in Florida. A lot of times I'll go to these models and I will upload them and send them to him so he doesn't have to come out to Oregon or Wyoming or wherever to look at the building. He can just walk through the model, take his measurements, and we can have a nice live discussion like we're having now and actually looking at the building without having to be there on site.
One of the best things when I was early on in my career and I was working for this old-time general contractor, he'd been through the mill, probably built hundreds of homes and had all kinds of different things happen. And he said, I go through and I take a picture on every single wall after all of the infrastructure is put in. And he catalogs that kind of similar to what you're talking about. He catalogs that as the building's being built so that if he ever has to go back with a customer or has an issue, he has those pictures at those different times of every single wall. So he can say, okay, yeah, for like you said, that pipe is in that wall in this location. And that's just a really smart thing for someone building a house to do in general. I did it when I built my house, but that's not a normal, I'm in the business, so I know to do that. And I was told that 20 years ago, but most people don't understand that having that ability to be able to see behind the sheetrock, behind the curtain, so to speak, is really impactful if something happens. So.
Absolutely. And, it's something you got a smart builder there, because a big part of what I do is get hired by attorneys that representing a contractor that got sued. And the first thing I ask them is, well, let's look at the contract. Let's look at all the construction documents. And, oh, by the way, did you photograph anything?
Yeah.
And it's more often than not, most of the guys that get stuck in this stuff will say, no, we didn't do that. And so on site, he took some photos.
Word for it.
Yeah. And then it ends up costing everybody a lot more money and time. Whereas the 3D models or the good photographs can really reduce the amount of time it takes me to figure out what's going on and, how to fix it. And you don't have to rip walls apart. You can just say, oh, well, here, this is where they connected things and this is what it looked like. It's just at a destructive testing. So in building science world, destructive testing is essentially when you pull walls apart to see what's there, why is it failing, what's going on. And it was a very extensive one. So it was all day. Sometimes these things take all week long, and we rip walls apart to see what are the different parts and pieces forensically to see, okay, is a failure. Why did this happen? And was it a design problem? Did things not get installed properly? A lot of what I push with these things is just like, it's just an ounce of prevention. You do these things throughout construction, then you likely don't have to be ripping walls apart later when there's a problem.
A secondary item to that, obviously, with the construction defect side and inventorying, we have that. You and I have collaborated on some cool stuff with the 3D modeling. We're on a project well away from where the owner or owners are. Some of those owners are even being international. And we're able to give them that walkthrough of the condition of their building. And then if we're coming in over the course of multiple years, they're able to see a progression or a change or degradation of the building. But then the other part of that is, like, we're working with a lot of hotel owners, and every so many years they're required to do a soft remodel of these hotels per their franchisee. So we're able to take those models very cost effectively and change them to represent what it's going to look post remodel. So we can easily take a room, a hallway, a lobby, and change elements of that within the model to give them those walkthroughs. It's really amazing what this technology has done for us in terms of efficiency. And because everything comes out pretty well dimensioned, we can take these 3D photos, 3D renderings, and convert those into 2D permittable plans, again, much more efficiently, effectively than what we could. I was just had somebody send me a photo of what drafting rooms used to look like. And it was these massive warehouses basically with guys laying across tables covered in paper. And now, I mean, it's literally a person at home. In the situation of as-built, you send out a guy. I mean, we did a whole 14-story hotel in less than a day using a 3D rendering, using our 3D cameras, where we had a full digital walkthrough, fully dimensioned, of everything about that building within a day. And if you were to go through and have to pull as-built on a facility that large, it used to be multiple people across multiple days measuring everything, measuring and dimensioning everything. Not the case anymore.
No, and that's even if you've got good as-built. I mean, one of the common problems we have in the construction defect world and in forensics is we'll get called, hey, we're having this building failure. Can you tell us what's going on with it? And first thing we ask, yeah, can I get a set of plans? And you'll find that, well, we don't really have as-built, or the city doesn't have them. So nobody knows what's there. And you get into these older buildings and they kind of start adding things and nobody's documenting it properly. It makes it a real challenge later for us because we got to go through and say, well, we need to know what's there. And so to Royal's point, that's one of the things that helps is we just model it and we're going to timestamp it and say, well, here's where everything is right now. Makes it 100 times easier than sending a guy out with a tape measure or even a laser measure to measure things. It just does it for you.
So these Matterports, is that what you're referring to, the Matterports?
Yeah, there's different mediums for it. There's a bunch of them on the market. Matterport's kind of like the Kleenex of the reality capture.
Gotcha.
And you get into laser scanning and that's, if you really want to get pinpoint accuracy, you do laser scanning and it makes a bitmap. I like to use things that give me photorealistic walkthroughs because people think in pictures and that makes more sense. Sure. The lasers, the bitmaps, they're getting better at overlaying those things. So they'll say, we get a laser scan. Well, we can overlay it on top of the photo capture. And so it looks really good and it's pinpoint accurate.
And it's scaling it and measuring it within an eighth of an inch, a half inch, a foot.
With lasers, they do it within millimeters.
That's pretty impressive.
Yeah, some of the really good lasers out there. And I don't want to name them because we're not getting monetized. And maybe if they want to pay us later, I'll make a list of them. For this discussion, though, I'll tell you all about the technology and how we use it.
Sure.
And then maybe we can invite one of those guys to sell their wares to everybody. And the technology is changing. It just keeps getting better and better, which is exciting. I mean, one of the things that I'm really looking forward to is, there's been some breakthroughs with quantum computing. And I think for us building nerds, there's going to be a lot of things that are going to come out of that, especially for the structural engineers and the architects are going to be able to compute new materials. It's going to be like, well, if we can calculate combining concrete and metal and glass and all these different things and things that we haven't thought of yet, that's really exciting to me. I'm an optimist, so I kind of see some really cool stuff coming down the pipe. We don't have to get into that too much now. That's like future casting stuff, but looking forward to it.
It's pretty highly detailed, and we've used it. We've used it on a lot of projects in different really versatile ways. So
I would say, going back to your point too, Royal, is that, one of the really valuable things that we do with it is a deviation analysis. And so oftentimes when we have these hotel clients and if they want to build something new, they get an easement agreement next to an office building or a garage or a condominium building. They say, well, we're going to build right next to you. We have an easement agreement. And if we damage your building doing anything, we're going to fix it. The old way of doing it would be that they would send a guy like Royal out and he would put crack gauges all over the building and say, well, here's what it looks like right now. Here's some photos. The new way is we just laser scan everything. And we say, here's where everything is within millimeters. And if anything moves or damages, we can tell you where it moved and how to fix it and all that good stuff.
Oh, interesting. So you actually stuck crack gauges on buildings to see and it was pinpointed to that exact location. And if it just moved a little bit, then you would know that maybe something is different.
Yeah. And, the downfall of the old way of doing it is that it's kind of myopic, right? It's like they'll say, oh, there's cracks in the building. Well, we know these are cracks. We're going to put crack gauges on it. So if it moves, we'll see how much it moved. And the problem with that is if you get like a pinpoint movement on a building, you say, well, just one corner of a building has settled. And, you come to find out like the engineer went out there and took pictures, but he didn't really, there's no real baseline benchmark for what that area of the building looked like.
Or
and then it's a huge argument.
Gotcha.
Right. We used to basically just, like you said, put out crack gauges, survey targets, and then we'd go intermittently to the project site if they were excavating or doing construction work adjacent it and re-site in to see if we'd had any movement or any existing cracking had opened up. But this now, gives you a full snapshot of the entire structure and where you can do a direct side-by-side comparison of anything that may have been pre-existing to post-construction. It's very prevalent, especially in very dense cities, dense population where you're
digging a giant hole next to a skyscraper or something.
Well, yeah, or a historic structure. That's the more common one, like the one we're working on in New Orleans right now is we've got a historic structure. 2 historic structures constructed adjacent to each other, and then a third historic structure going through massive renovations and elements that, unfortunately, there's elements of all 3 of those buildings that are tied to each other. And so they're moving at different rates. They're having different issues. And so to be able to go through and do a full model of those and see where things are at intermittently is great. And the images that these things pull is extremely highly detailed. He's setting a camera up that maybe 10, 12, 15 feet away from a retaining wall. And I'm able to zoom in on that retaining wall and see if there's even a fine line crack. So it's very highly detailed. So let's dive in more into what we're going to see in with our residential construction. And that's more like with the energy code. And the big thing with energy code is common statement is build it tight, ventilate it right. So what are you seeing and how are we tracking or managing as far as water tightness, and what possible other things are we seeing as far as when it's built tight incorrectly? So
yeah, that's usually the stuff that I see. I get a lot of these. What I found is you see a lot of the same kind of mistakes happening all over the U.S. and when you have different climates. So you'll see the same mistake in Florida, but it manifests differently in Florida than it does in Washington and Oregon, right? Because we have the different climates that we're dealing with. Just anecdotally, I just went, I had an inspection in Orlando, and to your question, one of the things that I noticed walking through this house was that the homeowner walked me through and was showing me, well, we've got leaks here, 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 here. We've got them at roofs. We've got them at windows. And, oh, there's water coming out of the wall outlet. And, these things can be very deceptive. So like most of the builders, they've looked at this thing. By the time they get to me, it's usually they've had a bunch of people look at it and they're like, we can't figure it out. So, I go out there and they go, oh, the water's leaking at the roof. And, you look at it like, well, no, what's happening is that you have these micro channels. You have air leakage around wall penetrations. You get this really, air conditioned, cool interior, and you have a very hot, humid exterior. And you have a path for that hot, humid exterior air to get into the wall assembly. And then it condenses on the cold surfaces because you got cold air leaking into the wall, mixing with that warm, humid air from outside, and you get this funky condensation patterns. And in this house, they actually had one of the vents, one of the ducts was disconnected and pumping cold air into an attic space.
Ooh.
And then they had they had an inlet vent in the soffit, but no exhaust vent. So you got this air from outside going into the attic vent, and then it's just going to mix with that cold air coming from the HVAC. And it's going to condense on any of the cold surfaces in there. So this funky water staying in the ceiling. And by the time I get there, everybody's like, oh, it's the roof's leaking. And like, no, it's just condensation. And we walk them through how to fix that. We see the same thing in the Pacific Northwest, or it's a little different where we have cold months and we have, we get hot, humid interiors through just normal human action, cooking, bathing, showering. Some people just like it really humid in their homes. Mm-hmm. Or you'll get water that comes up through soils. I've seen that a ton of times. And you get a stack effect. And so oftentimes what I'll see a lot in Seattle is they'll have these flat roofs and they put the insulation on the wrong side. And so if they'll build it to code, they'll say, well, here's what code says. And like, well, yeah, it's got the right R value, but you have air leakage going from the inside up through the attic space, and it's getting to the roof sheathing, and it's condensing, and then it's just wreaking havoc on these buildings.
Yeah, generally they have, like at the soffit, they have a vent, and then there's like supposed to be a 1-inch air channel, let's say, on a flat roof going all the way through up to a roof vent at the peak, let's say, or the higher point, right? A roof vent or a ridge vent or something like that. And so you're saying when they have it on the wrong side, does that mean that the insulation was put like up against the roof sheathing or up against the sheetrock, or what do you mean by the wrong side?
Oh, well, that's a good question. I'll clarify there. So if you get a pitched roof, typically you want it ventilated, and air goes in at the bottom, goes into the eave, and then comes out at the top. And so you kind of get the air wash through your attic space. When you have a flat roof, typically they're a truss system, so they're flat. They have a web truss system, and they have roof sheathing, and then whatever your roofing is above that. And inside that truss space, oftentimes people will put in bat insulation. So they'll say, well, I've got R49 bat insulation. They fill that space up with insulation. And then you have that dead air space in there. And with flat roofs, it's really tricky. If you're going to ventilate them, it's very tricky to get them ventilated properly, so you don't have these weird dead zones, right? So if you go, well, I want an unvented flat roof, well, you want the insulation on the outside. So now you move the dew point outside. So if you get a nice thick exterior insulation, you stick it on top of the plywood before you roof. Now any air that comes from the inside, it has to get through all those layers before it reaches the dew point of the interior air. So that's what I mean by they put it in the wrong side. So
it needs to be exterior versus interior.
Yeah, one of the things you see a lot of is spray foam. So it's not bad. There's nothing wrong with spray foam or doing these systems, just understanding how they work and doing them correctly. And so it's like people have the right idea, and then they just miss key components. And so what we see a lot of is guys will say, well, we do what's a flash and bat. It's called flash and bat. And so they'll put like 3 inches of spray foam to the bottom side of the roof sheathing, and they fill the rest of the cavity up with bat insulation, and which is all well and good, because it's kind of like, oh, well, we've stopped the air from getting up through there. The problem is that stuff moves. And if you got wood and metal and all these connections, these things move, and they create these little channels for air and joints in the plywood. And when you have wall to roof interfaces, those are often overlooked, and those all create little paths for air to get up into. And so you get that air moving from inside to outside in those cool spots. You get condensation, and the roof gets wrecked.
Gotcha.
You're making me think about my own roof because I have spray foam. I have spray foam in my new house. I'm like,
but you're in Florida, it moves different down there. You got to worry about outside air getting in. So
right. Yeah. Well, they did a full sealed roof system. So actually my attic space is part of the conditioned air space. So So they did a fully sealed, no top penetration system. Even my exhaust vents for like my bath fans and stuff are actually down in the lower eaves, and there's no actual ventilation for the attic space. Everything's just sealed in and made part of the conditioned space. So, which we see not so much that in Oregon or the Northwest, but in the reverse of that, something that we promoted with a lot of builders, especially in very damp environments, is making the crawl space part of the conditioned air space. So doing an encapsulated crawl space. Because to your point, the most amount of water we're typically getting into the home's envelope is from the ground. The code is just foundation vents and visqueen over the dirt, a 6 mil black visqueen over the dirt. And that isn't stopping a lot. An encapsulated crawl space, we're not doing floor insulation. We're not doing venting. We're actually doing a perimeter insulation around the foundation. And then they're actually using material that's equivalent to a TPO roofing material and sealing it to the home's rim board or to the foundation, to that insulation. And even all the joints are sealed. And then they're putting in a dehumidifier. They're putting in a sump pump system. And then one house, a development we did on the Oregon coast, we actually didn't even do any ductwork in the crawl space. It was a full blast plenum. So we did full encapsulated crawl space, made the crawl space a plenum for the HVAC system. And the people that bought the homes there, they loved it because they were like, our floor is always warm or it's always cool. When it's hot out, the floor is cool. When it's cool out, the floor is warm. And then if they did have to do work in their crawl space, they're climbing down into something that's fully sealed. There's no mud, there's no dirt, there's no bugs. Everything's fully sealed.
For the non-scientist and the non-engineer on the call.
Yeah.
I've seen those clean room underfloors that you can basically eat off of the white. Like it almost looks like it's like a membrane or something like that they put down there. So what you're saying is they essentially seal everything to the foundation, then insulate the foundation stem walls, and they actually use that whole chamber of the underfloor. They heat that whole chamber underneath there. So the whole entire floor throughout the whole footprint is heated, basically, because there's just vents where they want that to come up. There's no ducting. They're heating that whole thing, and they're just putting a floor vent where they want that heat to come in.
Yeah.
Wow, that's interesting. And that's more efficient than putting ducting in. And it seems odd, like you're heating a large space underneath there. I'm just posing the question.
Yeah.
It seems like you're heating a very large space underneath there, constant rate, and then you're punching holes in it to pull the heat into the house. That seems like a lot of
essentially what you're doing.
Heat. Versus
Usually those things are balanced. And so if you have, if you use your crawl space as a plenum, whether it's a return plenum, so if you have air that's ducted and it comes down, it goes down through the floor, that goes back up into your HVAC assembly. And so that floor plenum, totally fine to do that. And, you're not using duct work. And so you get this nice, if it's done right, you can get a good, nice, even heat distribution throughout the house. It can be more efficient. That's definitely one thing you can do. And I do like having the conditioned crawl spaces because, that way you don't have soil gases coming up in your home. You're keeping soil moisture from coming up in your home. And, for the non-science people, when I said stack effect, typically what we see is if you get, even on a 2 or a 3-story home, because heat rises, it creates kind of this vacuum. And if you have an unsealed ground cover, like Royal was talking about, that soil moisture gases get sucked up into the house. And it'll add a bunch of water that, and anecdotally, I've had a bunch of clients that were saying, hey, Nate, I've got 12-foot overhangs and I've got water coming out of the windows. And this doesn't make any sense to me. It's not coming from rainwater. And I have to physically show them that, well, what's happening is you have a vacuum. You have the stack effect. You have a very wet crawl space that's getting sucked up, and then it's just turning your house into a hot air balloon, essentially.
Gotcha. And I know that, that's the majority of the houses in the Northwest are just that 6 mil visqueen that's got to run 12 inches up the stem wall and use the foundation vents. And so that moisture will make its way around that plastic on the perimeter of the building and then start to be sucked up into the underfloor plywood joist and kind of thermally transfer through that kind of initial barrier and then be pulled up through into the wall cavity and up through into the windows.
Yeah, this kind of goes back to the air leakage discussion. It's something that I've been asked this so many times over the years. Guys will kind of, there's a lot of entrenched conventional thinking or from people that just don't quite understand the physics of how fluids move, and air is a fluid like water. And if you think of a wall stud and a piece of sheathing, right? So we put the wall studs up and then we nail the sheathing to it. Well, that's not airtight.
No.
And so what you hear a lot of guys is like, well, where does the air come through? Like, well, all the joints between your studs and the sheathing and the sill plates and all this stuff, it's just micro channels for air to move. And if you have a pressure gradient, you're pumping air into your house, you're turning it into that hot air balloon, or you're sucking it, you got a dryer and a flue and you got a kitchen fan, all this stuff. And now you've turned your house into a vacuum cleaner. You don't know where that air is going to come from. You don't know where it's going to go. And, that's the importance of understanding how these things work and sealing them so we can control it. And to Royal started the conversation with tighter buildings. Yes, it's a requirement. But people forget, like, you still want to control where the air comes in, and you want to make sure we get proper air changes. We're ventilating so we have a healthy environment, but we're not adding exterior contaminants or too much moisture. We kind of want this nice balance where we keep the the humidity range down between 30, maybe 50%, and it's clean air, and we're, slightly positive to the exterior. Those things, those are all things to take into account. We're talking to mechanical engineers. We kind of tell them, hey, we're sealing this thing up really tight, and what kind of mechanical system are we putting in? Are we doing a split system? Are we doing a radiant system? Where are we getting outside air? When we turn on the kitchen exhaust fan that's going to suck 200 cubic feet per minute out of this kitchen, well, we need to have some relief air that comes in so we're not turning our house into a vacuum.
Yeah. Does this have to bring in the Pascal's conversation, outside versus inside, and the balancing of that?
I love
it. Pascal is just a unit of measurement. So typically you're going to have a pressure differential of, it's very, very minuscule, and it's hard to measure. It's hard to find meters you can actually measure that minuscule. We're talking like 4 to 5 pascals. Mm-hmm. I've seen buildings. I just had a conversation with a university client that said, hey, can you come look at this building? It's leaking. And also, by the way, the doors are hard to open because it's under really heavy negative pressure. And I'm like, well, that's probably why it's leaking, because you've got an imbalanced system. So you're sucking really hard and you're drawing water and all sorts of stuff through your building. You get condensation, you're going to get water leaks. You need to have a balance of where's the outside air coming in and how does the system operate. So you're just slightly positive to the outside and you're not turning your building into a wind tunnel.
Yeah, I know just from working for some of the production builders around here, a lot of them have utilized that fan in the utility room as a way to, there's an automatic kind of on-off switch. There's a switch, but then there's also some type of on-off mechanism that's drawing in air at a certain rate so that it's balanced for the number of air exchanges an hour that are supposed to happen based on the path or in Washington, the points that you're trying to get to. If I remember right, it's 3 to 5 air exchanges an hour is most common, I think, right now. And industry as a whole seems to be trending to get down to like 1 air exchange an hour, which requires kind of more mechanized and concentrated air. Is it ERV? Is that what it is? ERV? To bring the air in, and then you have less air exchanges per hour. And that just kind of goes to what you're saying is, if you make the building too tight, then you don't have anywhere to expel the air, and you could be bringing in contaminants that can't get out, right?
Yeah, and it's just understanding these things. And I'll give you another anecdote of a community that I worked for that they had I've written a blog about it just recently, what they thought was a roof leak. So one of the homeowners called and said, hey, we just had work done and the roof's leaking. And I went and looked at it, and they'd already hired a roofer. The guy was ripping the roof apart. I'm like, this is not a roof leak. And,
Wow.
In a nutshell, what it was is they had this really powerful clothes dryer, and they would turn the clothes dryer on and it would pump air out onto their flat roof. And then they had 2 bathroom exhaust ducts right next to the exhaust for the dryer. So the dryer would kick on, and it was so powerful, it was drawing air back in through the bathroom exhaust fans. And so it was really cold, and that, moisture from the bathrooms, and it was just condensing inside the ductwork and then dripping into the ceiling.
Oh.
So, that's one of those imbalances in an HVAC system. It was like, well, you need to have outside air. You need to control where this air goes so it's not getting sucked back into the building. And, those are things that ideally you work with a good HVAC contractor, a good mechanical engineer up front while you're designing the building before it's a huge problem. To your point, it's like, well, what kind of system do we have here? If it's a forced air system, okay, they have automatic dampers with an outside air duct that comes in and it's pressure regulated. So it gives you that makeup air if you need it. And you just need to plan that stuff during design.
Yeah.
Yeah. The tighter and tighter we make the buildings, the more we have to account for these different things. And and then there's things we're doing supplemental to try and get this reduction in air exchanges, or there's just types of construction that are just inherently tighter, like ICF. And ICF, I love ICF a lot. Its durability, its air tightness, its insulation values. But if the mechanical is done incorrectly, it is a hotbed for damaging of the home. Whether you talked about creating a relative humidity of 30 to 50%, people don't understand that you need that humidity. If you dry it out too much, you're going to have damaging effects to elements in your home. We got called in on one where it was so dry in the house, their wood furnishings were cracking, their wood cabinets were splitting and cracking. And then inverse of that, too high of the humidity, you're getting into sweating windows, mold growth. Even though you are exchanging the air, it's just you're not controlling the humidity. So if you're going to make it tighter and tighter, you need to properly ventilate it, or you're going to result in bigger issues.
Yeah. And, one of the things that I hope I can impart to builders, and this will kind of dovetail into the QA, QC programs for construction. I mean, one of the things that I tell developers and builders all the time, I get asked, hey, this thing has failed, but nobody's maintaining it. And so the first thing I ask them is, well, I understand that. Did you give them a maintenance manual? And typically the answer is no. And it's like homes and buildings they're like our cars. They need to be maintained. There's things that you have to do on regular intervals. And, we've been picking on HVAC on this discussion quite a bit because rightfully so. I mean, that's one of those components that you do need to maintain to make sure that it's functioning right and the filters are clean and dampers aren't. I see this stuff all the time. And, like I just saw one recently where the litigation and the consultants are like, oh, the walls are leaking and it's leaking around roofs and everything else. And I go and look at it like, no, what they did was put a bird screen on the kitchen exhaust fan and the vent won't open. So now all that air from the kitchen and the bathroom are just getting pumped inside the walls. It's condensing and the walls are rotted. And somebody doesn't know, it looks like a bunch of leaks and the wrong people get blamed for something. So, maintenance is critical.
Absolutely.
Change that air filter. Change that air filter.
That's right. Make sure those dampers are working.
That's right.
So you kind of hit on the maintenance aspect of it, and that's a big thing. But in general, what are common causes or real root causes that you're seeing that are resulting in damage or leading to like construction defect lawsuits?
Yeah, I mean, anytime you see any sort of something that's out of the normal for whether it's a building owner, a homeowner, hospitals, whatever the case may be, people will see stuff like I got a call today about nail pops and drywall. And they're going, hey, I want to sue the builder because there's nail pops in my drywall. So visual things will set off a construction defect lawsuit before somebody really knows what the issue is. And I'll tell you a funny anecdotal story. I had a case in Seattle there was about 5 or 6 experts all standing around looking at a puddle of water in the middle of a room, and they were trying to decide what was defective. Where was this water coming from? And it didn't make any sense. So I'm looking at it, and I'm like, And so I go over and smelled it. It was cat pee. There was a cat that would come over and the cat would piss in this one spot. And so it got to a level of attorneys and multiple experts trying to figure this thing out. And I was like, you guys, it's cat pee.
Did you taste test that, or
you could smell it?
It's just professional expertise.
Didn't need to taste. Yeah, that's right. You did do the taste test on it. How
I can think of a joke. How many forensic experts does it take to solve a puddle of water?
Oh, man.
Should have got it DNA tested and everything else. That was the next step of it.
Oh, boy. So, I mean, really, I think overall our discussions really hit on a lot of the things. I've expressed this structurally, and it really is a big key overall in the house. And that is, over the period of about 2.5, 3 years, I was the engineer of record for over 2,500 foundation repairs. 99% of those foundation repairs, and probably even over 99%, could have been avoided had they managed the water correctly around the home. And now this is a situation where as we build homes tighter, or with our flashing and our building envelope, it's managing the water that's falling on or against the home, or the moisture content of the air coming into the home. So basically, water's the problem. Just get rid of all the water, get rid of our reliance on water. That's
it really is. I mean, I would say like probably 98% of the cases that I've worked on throughout my career are related to water in some way or another. To your point, it's like, when you design, I always tell architects and engineers and design build contractors, like, look, just look at your building and eliminate as much of the water as you can. You got to worry about drainage, how the water's going to hit the house. Where is it going to go? You need to deflect it. You need to drain it. You need to do the same thing on the ground. Where is it going to go? You need to divert it away from the house and the foundation. And hopefully you're not dealing with these heavy clay soils, expansive soils, because that's a whole other issue. It's like, well, okay, we've waterproofed the house really well. We kept the rainwater off of it. We managed the interior, but oops, we have every time it floods around here, the soil is expansive and now our house is cracked and warped and everything else.
Right. Yeah.
It seems like a lot of the time, again, I can just speak to the experience in the Northwest, that there a lot of people like to point the fingers. Is the flashing done right? Has the way the path for the window flashing, let's say, has that been done correctly? And it seems like I just hear about that a lot. Are the windows flashed and is it leaking there? I think a lot of people just point to that initially. Have you seen that a lot?
Oh yeah, those are all low-hanging fruit, right? So the first thing that people look at, people in the industry will go, they ask me, the developers, like, hey, I don't want to get sued. What do we do? And you tell them, like, do these things and get well, we're not going to do that. Or, and so we try to make it easy on them. But that's the first thing a lot of consultants will go and look at is, hey, you punch holes in your walls, and windows oftentimes are inherently leaky, and they're, different materials. So they expand and contract at different rates. And did you flash it right? And there's multiple ways to install and flash windows. And I would say, like, everybody has their own preference. Mine's the one that doesn't leak. That's my preference. And so you'll hear a lot of guys that they'll poke holes at something and they'll say, we call it technical deficiencies. They'll say, well, you didn't install it precisely to this one manual that I have here. And, oh, okay, is it leaking? Well, no. Well, then I don't think it's a problem, but it's created a problem because the psychological aspect of it is that someone says, well, you didn't install that right. If you didn't install the brakes right on my car, I don't want to drive it until they're done right.
Yeah.
Right.
In the one other thing that comes to mind, and I feel like when I started my career in the early 90s, that just dated myself, but the felt, the whole old timer, hey, you need to put felt on your walls. And now we're talking house wrap. They used to put a lot of felt on the walls, and then Tyvek came out and it was flat. And then Tyvek went to crinkle wrap, which is like kind of almost like a rain screen, pseudo rain screen crinkle wrap. And then, commercial buildings now have a rain screen where you're putting furring strips on there and all of that. And do you have an opinion on like the old timers, like, hey, felt will never leak, versus the industry's kind of changed now into these more sophisticated building wraps, synthetics and stuff like that?
Sure. Yeah. And I'm going to be careful about putting product names in here because I prefer to get paid for that. But
that's like Kleenex. I use Tyvek as Kleenex. I'll just set that straight. So nothing against Tyvek. No,
you're fine. I'm just playing. So, really one of the things that you're absolutely right. I've heard that my whole career. You guys would be like, well, I've been doing this 30 years. I've been doing it 40 years. And all you need to do is X, Y, and Z. And typically my response is something like, that's fantastic, but that component you're putting on the wall came out 10 years ago. So you haven't been doing it for 30 years. And we're building differently now. We use different materials and they're more moisture sensitive, and we're not putting overhangs on buildings. Things are just different and things need to be compatible. And you're building a home that's got 10,000 parts in it. There's nobody that's going to know everything about all those parts and which ones are compatible and which ones aren't. You can get pretty good, and you just kind of, I always tell guys, just take a systems approach to these things. Sure. And find to have kind of some industrial knowledge, right? So you've got this knowledge that, hey, I've been doing it this way and it holds up just fine. But, guys like me, I will sit with them and go, well, here's why what you did is different from what we're doing now. And it's not right or wrong. It's just something that things are just done differently now. And, there's a value to doing it with old felt paper, and with overhangs and air leaky buildings that dried out. It's all good stuff. But then you do that, you're going to get sued for having an air leaky building that's not energy efficient. So don't do that.
So where do you see the future of building science really going?
That's a good question. I think it's going to be more and more adopted by engineers and architects. And I've seen this arc over the last 20 years of doing this stuff where people are keying into it a lot more and understanding like, oh, okay, the science and the physics behind all this stuff is really important, not just making a pretty building that's not going to fall down. There's a lot more to it. I think this where it's headed, we're going to start incorporating a lot more, AI. We're going to incorporate things that are more anticipating of how a building's going to perform. So when I go back to when I was talking about quantum computing, there's going to be a lot more modeling. So the modeling people are typically using like Woofy and Therm, and there's a few other ones on the market. They definitely have a utility and BIM, and they're great. But something that you model isn't necessarily how it's going to perform when you put everything together. So where I see the industry going is going to be an amalgamation of modeling and getting actual empirical data, fixing the models, and it's just going to be a bunch of things kind of all coming together and more builders understanding how these things work.
You think climate change will play obviously we don't have a crystal ball, but is climate change kind of play a factor in the advancement of what's happening within building science?
Absolutely. Yeah. Most building science nerds have an eye towards climate change.
Hey, Bill Gates said it's not a thing anymore.
It's just something you all have to, as designers, as people in buildings and the manufacturers of components, we all need to be aware of those things. Or not to go too far off on a tangent on that stuff. I just look at it as with better computing, we're going to have a better understanding how things are going to perform. And it's just putting in good data. And, I'll give you an anecdote on that stuff. Like we don't see a lot of vinyl siding anymore. And it's not that it was a bad product or it was, there's things I liked about it. It was kind of like naturally ventilating and it drained and, so it was a very forgiving product, but it shed lights on things like UV exposure. You'd see a whole side of a wall that was melting because there was one window that was reflecting the sun, and you get a point load, it was heavy UV load, and the stuff would melt. And so that's something that we would say, well, that's climate change, right? And in a way, because you're looking at it from when you design a building, hey, how's the sun going to hit this thing year round, and it's going to hit the windows, and what's going to happen what kind of solar loading are we going to get through into the interior? What's going to happen, surrounding buildings? If we build something that's very reflective, UV bounces off and it burns somebody's cat, are they going to sue you for it? So those are all things we want to think about.
Not the cat.
Yeah, I guess the life cycle of a house does play into that. If a sticks and bricks house is a 100-year building, how's it going to perform over the term of its life cycle?
Yeah.
Hardy plank siding. Oh, again, I can't drop names. Cementuous siding.
Has we're using a lot of
fiber cement. Yeah. The fiber cement siding and. We'll be very generic.
It has been for like the last 20 years. So it has a 50-year warranty. It's really fire retardant, et cetera. And so that performs over the long term so far pretty well.
And then building facades are very climate appropriate, right? So, what we're using here in Florida, you're probably not going to be using in Arizona. What you're using in Arizona, you're not going to use in Oregon and Washington. Nate, you and I were both part of quite a bit of that as we got into the industry, because that was when unfortunately, they were doing a big push of stucco and EIFS into the Northwest, and they weren't doing it right. And it resulted in a lot of issues.
Absolutely. And I still see the same thing all over the country. We'll just pick on climate, period. Understand the region and the climate that you're building in. And I always tell guys, just because you can interpret the code and say, I can do it this way, doesn't mean that it's a good thing to do where you live. It's really common for design professionals to kind of get a name for themselves, or they'll get these national builders and they'll design things like, well, that's great for Arizona, but if you build that in Seattle, it's going to leak and it's going to rot and you're going to be in trouble. Same with Florida. You see things that guys are like, look, this is a hot, humid climate, and stucco is very popular down there. Well, how do you put stucco on the wall? You put metal lath on. So you're poking holes all through your wall to attach this reservoir cladding. So stucco, because it's a cement plaster, it's going to hold water. And in a very humid climate, it rains, it holds water. And then as the sun hits it, it's going to dry into the wall. And so if you don't have a proper wall assembly, the wall is going to rot. So those are little things that try to impart to people, that just think through your environment when you're designing something, and ask people. You're welcome to reach out to me and other building science nerds, and we'll help you through it.
Yeah, we have a house on the coast, and 1,500 feet from the shoreline, that entire home has all stainless steel fasteners, stainless steel flashing. Everything about the way that house was built was different than even just an hour and a half inland where I live now. And so very, very different based on the climate and the marine layer that happens on the coast versus, even though we're still kind of in a marine layer in Portland Metro, completely different products out there on the coast than you would do here. So.
Yeah, you get a pretty immediate reaction. When you build wrong on the coast, really quickly. Yeah. Stuff starts corroding, it starts leaking. And
siding has about a 10-year lifespan out there, no matter what you put out there. And it just,
it's tough.
Paint degrades really quickly. And
I'll share a quick story on this, and then I want to hit back to you, Nate, on additional services I know you offer. But I did a structural investigation on a home on the coast that was only 1 year old, and they had flashed and sided incorrectly. And this was like a 3-story house, and they had a massive opening, massive slider that had a 5.5 inch thick, so 6-inch glue lamp over the head of the door. And we were demoing to do some destructive investigation. Again, house is 1 year old, went through one winter. How degraded is that big beam that's holding that opening? And I put my hand through the beam.
Oh my gosh.
That's how degraded it was. I was able to put my hand through the beam.
Is that right on the coast? Is that like
it was waterfront. It was waterfront in Oregon, because when you're, especially in a lap siding situation, people aren't thinking about how wind actually drives the water upward. And so when you're putting in a lap siding scenario, and then you have a direct wind in an exposure D environment, that is a lot of force, and that can actually drive the water upward in that lap siding. And that's exactly what was occurring. And then they didn't have it properly wrapped and flashed to allow basically water to flow between the wrapping that they'd put in and for it to escape out through like a rain screed. Found its way in. It always finds the path of least resistance, and it was able to decay through a 6-by beam in 1 year. So,
it can happen pretty quickly. I mean, one of the things that I see a lot of is people covering stuff up wet. I've had quite a few cases where the conventional wisdom is they go, oh, it's leaking and the walls are rotted and the framing's rotted. And, I go look at it and go, well, no, they waterproofed it really well, actually. They just cover everything up wet. The framing was wet. The sheathing was wet. And some of these guys, you ask them, like, well, what were you thinking? I mean, building code says don't cover it up until you have a moisture content less than 19%. And, these guys are like, well, we tested it in a couple of spots, and then we covered everything and we superheated the building. And you go, oh, well, okay.
That's how they all dry out their framing, is those giant dragon heaters. And they do the sheetrock too with propane heaters.
Yeah, don't do that. It adds moisture. Propane heaters, you're just adding moisture to the buildings. And if you have materials, like I'll just use OSB, for example. If you have a material that has a perm of less than 1 and you're trying to dry it from the inside to outside, it's not going to happen. It's just
predominantly a lot of builders do it that way. I mean, when I was a PM, I've walked into buildings that the sheetrock, the mudders and the tapers are trying to dry it out, and literally giant drops, just the entire ceiling's just covered in droplets, And it's like, well, it's kind of counterintuitive here.
I don't want to pick on low hanging fruit with some of these guys. I'll just, we'll share stories of silly things that people do. And I had an old colleague of mine, we went to a place on the coast. Similar thing. They said we were hired by the architect to oversee construction and kind of help with the design and make sure things were put in correctly. And so one of our mandates to them was, hey, do not cover anything until it's dry. And so they gave us a call. Hey, it's dry. We're ready to cover. We're good to go. And so I went out there with my colleague, and he gets up and pulls down they had wrapped window flashing peel and stick inside of the window. And now from looking at everything looked dry. It was like, oh, this all looks dry, and you can kind of probe the sheathing, and it was dry. And so my colleague goes up and pulls on the flashing, and just gallons of water come dumping into the building. And like, this is why we do this, guys.
So the last thing I wanted to hit on is what we're seeing in the building industry is definitely and it's beneficial overall for a lot of people, but we're seeing definitely an increase in entry-level townhomes. And I know for a fact with the builders we work with is their insurance companies typically requiring a building envelope specialist to provide detailing and other stuff like that. Is that something you do for these builders?
Yeah. I mean, one of the things that we call it a BERM, a building envelope reference manual. And I always recommend people have it, even if it's not required. I mean, typically people will come to a guy like me and say, oh, well, the statute requires that I do this. I have to do it. And which is never good, because then they're kind of grudgingly doing it. They're not really listening to you anyway. The smart builders will come and say, hey, how do I not get into this mess? And to your point, I always tell them the reference manual is to say, let's take all of the details. Everything that you're going to put on this building is going to be in one spot. You're going to tie all of your subcontractors to it. You're going to show the people you're selling the homes to. Everybody says, here's the manual for the building. Here's everything that we put into it. And it just gets that sheet of music that everybody's reading from, instead of, John brought this up earlier, instead of somebody saying, the builder just saying, well, I hired the roofer. He's a roofer. He knows what he's doing. And, well, he might, but he's just going to do whatever he feels like doing, unless you say, here's the sheet of music. We're all reading from this. If you have questions, call the guy that wrote it. So that's one of the things that I do, or, our team does for people, is we just say, hey, here's a berm, get everybody on the same page. And, we tailor it to whatever design people are using.
Gotcha. Yeah, those berms have been very helpful. And then one thing we did in partnership with you on something was we took that berm and then we actually made sure our details all aligned. And then we actually put in QR codes on our architectural details of those building openings. And so then the framer or whoever's out there doing it could have our plans, scan that QR code, and it immediately took them to the section or page in your berm where that was at. And your berms are very comprehensive. I mean, they literally do, they're great. They pull in everything from the different manufacturers' requirements. They provide kind of a step-by-step overlay and a rendering. And, I think that's in replacement of, or frankly, respectfully, in addition to having a mock-up on site of how a proper window assembly, door assembly, everything that goes in to dry in those openings. That berm is highly, highly beneficial. And that was a cool thing that we were able to offer that builder. And that was a builder that was building directly waterfront. They're highly susceptible to water infiltration. So it was really cool to be able to do that. Well, awesome.
Yeah, they're really handy. That's one of the things I see a lot of in the construction defect world is, a lot of it's caused from just bad communication, either a bad design and people relying on people that they shouldn't be relying on. And, it's the bad communication starts with these things where it's like, I've had multiple developers tell me, well, we got the structural drawings, we took it through, we got permits, and you go, cool, or where's the rest of the details? Well, we don't have them. That's up to the siter, that's up to the roofer and these guys, and they're all putting God knows what on these buildings, and fails, or things aren't compatible, and that fails, and then everybody points the finger at each other, and it's just messy.
I don't know what you're talking about. Nobody points fingers at others. No, that never happens on a job.
That never happens in construction.
Never. Yeah. Just always blame Steve. It's always Steve's fault. That was my joke always on the job site. Somebody parked their truck over there at Steve's. It's Steve's truck. So.
Now we've done this, people are going to say, did you test it for cat pee?
You're right. There you go. You never know. It could be cat pee. That taste test. Yeah. Well, awesome. Well, hey, I really appreciate your time today. John, did you have any additional questions?
No, I think we really hit on, air leakage, technology, data, the future. I think there was a lot of good about just a lot of good stuff in there, especially for people that are going to be building a house or going to be working with a general that's doing it. Just contact your local building science guy or try and put together all of your details so that they all intermingle, and make sure you do a good QA, QC on all of that stuff throughout construction. I think that's the key.
Bill Nye would have been way cooler if he was a building science guy.
Right.
So.
I agree.
Yeah.
I just need to start blowing stuff up too. I think
there you go.
Make things way more interesting.
There you go. Very cool. Well, Nate, did you have any closing comments or thoughts?
No, I appreciate you guys doing this. Always fun.
How do people find you? How do they get a hold of you?
They can look us up on LinkedIn. They can look us up online at csforensics.us. We got a website, LinkedIn. We're on Facebook and Instagram.
Awesome. Awesome. You travel nationwide. You and I have worked on projects together, Hawaii, Alaska, obviously the Northwest, Oregon, California, Washington. Now we're talking with projects over here in Florida. You recently had one in Wyoming. That was pretty interesting. Always cool when there's icicles inside the hotel. That's always a cool building
unique
effect.
one. Yeah.
So really appreciate you coming on. And I think you'd definitely be a regular guest with us because you are a wealth of knowledge in things that really cost builders a lot of money, that can be rectified actually very inexpensively. So building envelope incorrectly results in not only aesthetic damages, but often structural damages. And the only way to fix it is to tear it out and redo it. And that is never, ever cheap. So I want to provide this service and this knowledge to people as we can. So thank you again for being here. Thank you, John. If you enjoyed the show, please share it with your friends. If you have questions for us, do feel free to message us. If you want to get a hold of Nate, he explained CS Forensics is his company. You can also reach out to PLIRIS and we can get you directly in connection with him. He's been a long-time assistant with us with our services, and he and I have worked together on multiple cases and assisted multiple builders with issues. And thank you again.
Thanks, guys.
Thanks, guys.